Hi, welcome to another video. So if you've been watching my recent posts, you see I had the Agilent Technologies InfiniVision DSO-X 2012A, and today it's become a Keysight Technologies. A Keysight, I believe, were a division of Agilent, but as of November they've sort of parted. Agilent are now doing pharmaceutical, energy, that sort of stuff, and Keysight are now responsible for the electrical and test equipment. So what I'm doing here today, I've recently purchased the Mso Upgrade Kit, so I'll give you a quick demo of that. And I've now enabled the 30-day free software. It gives you Serial Decode, so I'll give you a little demonstration on that. So it's quite expensive. This Mso is a mixed signal oscilloscope. You get 8 additional digital channels down the bottom. It's quite expensive. It's about £600, including the 20% VAT here in the UK. So at £600, it's obviously worth knowing what you're going to get for your money. This Serial Decode I'm going to show you today hadn't previously worked on this model. This was one of the first editions, and I've been speaking to the guys at Keysight down near Berkshire, and speaking to a couple of guys called Joel and Aaron, and they're very helpful. I understood on this model, every time you press the serial button, it kept on saying on the screen, Serial Decode not available on InfiniVision 2000X series. So I thought, that's it, I bought a sort of expensive but scope that can't be upgraded. But speaking to Keysight, they put me right and said no, the firmware was an early version. On the early versions, with that early firmware, the Serial Decode wasn't available. I've updated it with firmware, and of course, as of last month, November, Keysight Technologies is now a stand on their own. This scope has now become Keysight Technologies, but very helpful guys when you phone the technical department. So I'll demonstrate the Serial Decode edition first, and then show you the digital Mso Upgrade I purchased. Right, so what I've done, press this serial button over here. As I say, that hasn't worked until today, so thank you very much Keysight Technologies. Right, so hopefully you can see these on the camera. So I'm on the RS-232 UART mode. I'll press that button and you can see various decodes, so you can I2C, LIN and SPI. So I'm using UART here today, and you get the signals, so transmit and receive on channel 1 or channel 2, thresholds on each, the bus config. So this is looking at the bus. You've got to tell it how many bits, how many parity bits, the baud rate. So if I click that, for example, so I've set this to 9600 baud rate. But if I click this, you can see you've got all the baud rates up there, 1200 up to 128 kilobits a second. Not sure if it must go higher than that. Didn't know it went that high. Look, 10 megabits a second. Anyway, I'm back down to 9600 kilobit, which is 1 bit every 1 millisecond, or 1,000th of a second. Right, so that gives you an idea of the bus. In settings, I've set it to, the bus will give me, I've set the bus to decode in ASCII. So because I'm transmitting letters at the beginning of the string, it will decode it down here. Then the framing, I've got, this is line feed and carriage return. Set that for the frame, and then you've got reset UART counters down here. Every time you get transmit receive, these counters count up and gives you any errors. Fortunately I haven't got any errors here, so I'll reset the counters. So what I'll do, set this up 1 second of division and enter a single capture. So we'll wait for 2 lots of UART strings to come in and see how well this decodes it. I've got the trigger on channel 1. You can actually have it trigger on UART, but because I'm capturing 2 lots of signals from 2 channels, I've just got it triggering on a negative edge on channel 1. So time is going to be Well, it's 1901 at the moment. Thursday, 11th of December 2014. Just approaching 1902. So a few seconds it's going to capture this data. What's this trigger? You'll probably see it trigger. And a few seconds later we'll have the data. There we go. So if I zoom you in a small bit. So remember, this is 10 seconds long, and there's our first capture of the time coming in on one Bluetooth, and this is the second Bluetooth with solar panel, current and battery voltage here. So let me zoom you in on this one here. There we go. So if you see my UART videos, you'll understand I transmitted or set this one to transmit time at the beginning of the string, and you see the decode working perfectly down here. It says time. I'm not sure about these gaps, but now I've seen it on the scope I can obviously look into it. If you're using a UART terminal on a PC, you don't get these gaps. So I guess this is beneficial. I can look at why I've got this long gap between the first letter T and then the second letter I. So you can see the string starts with time. On this scope, it's the Bluetooth sends least significant bit first. So this scope is set up for the least significant bit first, and then obviously swaps it around, reads it from left to right. So another issue is, so I'm transmitting the time, then the time string, and I haven't put spaces, but yet there's spaces here. So it's obviously decoding your UART. You have something simple like UART. I've obviously got problems here because there shouldn't be spaces. And that would answer the question, when I was decoding and passing the data, I would expect that the first part of the time, so like down here 19 for 1900 hours, they should be up here. But I wasn't getting the 19 until I counted down so many spaces. On the UART terminal, you don't get these spaces. You have to figure out where the time starts and stops. You just get blanks on the screen. So this serial bus decoder was bloody excellent. So if I scroll you along, so you see the time here when I captured it. I'm going to zoom you in. So the time was 19, and look, space, space, space. So I can look into that now I've got this software. 19, 2, space, 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 4. Not sure what this 2 is, but it's 4 minutes past 7, and that's the 11th of December 2014, and then you've got carriage return and then line feed. So with this serial decode as well, rather than me scrolling along looking for the second burst of UART, come up to this search here, press that, and it gives us the data in this scroll lister, well, scroll lister they call it. Not sure what the lister means, but anyway, so if I hit this button I can now scroll up and down through the list, and it starts from the beginning. So back at the beginning, so you can see the time there. Then I've got these spaces that I can now look into. So it's 19, not sure about the 2, and you see the time it took for the signals. So 1 millisecond, which is right for 9600 baud rate. There's a delay there, look, 2 milliseconds, so that's twice as long as it should be. And then we've got the 11 for 11th of December 14, and you can see as I'm scrolling down here the waveforms going off to the left, and now it's jumped to this second bus. Saves me scrolling along. So this is the solar panel charging current, and it starts with solar for solar panel. So I've got lots of spaces. I haven't put spaces in, as I say, but I think that's a Micro C Pro for PIC generating spaces. Not sure why. Then you see there's line feed. Then oh right, so the solar, and I've got one for charging current because it's 7 o'clock at night and we're in winter, so there's no current being produced. And then power is the actual battery voltage. So scroll down through there, you can see the data underneath. So the power, space, and it's a 12-bit analog to digital converter, and I got 656, and that converted from the strings gives me a battery voltage. Then we've got another line feed, and that's it, that's the end. But you can see here, look, that's that 5 there. I don't know if there's a delay in the analog to digital converter. That's taken 6 times longer than it should do. So that's a serial decode. Fantastic. Takes all the guesswork out. Saves having to you connect one of the UART devices to your PC and read it. And as I say, it doesn't give you these spaces. It doesn't tell you that there's a space. You can just see on the decode on the PC there are spaces, but on the scope it's all done for you. And I've set the bus to decode into ASCII. I think if I bus config down here, so you've got least significant bit here. This is the polarity of the bus, so it's idles high. Baud rate, parity none, 8 bits. Settings. So I'm on the, as I said, CR for the framing, carriage return, and base is ASCII, but you can change this binary or hex. I've got it on ASCII because I'm expecting these ASCII characters. So that's the serial decode. Fantastic. So while I'm looking at the scope, you might have seen the label at the top. It says MSO enabled, so that's a mixed signal oscilloscope now. So if I get rid of this serial, just back to 2 analog channels. Now what I've got 8 channels wired up to my PIC microcontroller. So if I turn on my digital bit, you can't have the serial decode with 8 digital lines. So if I unplug this is the lead that plugs into your scope. So not cheap, £600 with the VAT here in the UK. So that's the plug. It's just 8 channels on this 2000 series Infinivision, 16 channels or more on the 3000 and 4000. So that plugs into there. So if I go for single capture, oh, except I've got it triggered on the wrong channel. So I can trigger on any one of the 8 channels. See there, 7 down to 0. So I'll trigger on data line 2. There we go. Right, I've set channel 1, the normal analog channel on this scope, to the TFT chip select. So that's what this one is here. But I've set these 8 digital channels to trigger on channel 2, so data line 2, and this is a bus down the bottom, giving you the result of these 8 lines. So it's set to hexadecimal at the moment. You can have it binary or hexadecimal. You can turn individual channels on or off, turn them all off, or set individual channels here, turn them different ones on and off. But I've got all 8 connected. As I say, 8-bit parallel bus going to the TFT. Set the thresholds, there's TTL or CMOS. See down there, we use it defined. That's the bus. So bus 1, you can have bus 1 and bus 2. but all this bus is doing is counting these lines and which is on and which is off. And obviously if you've got 8 lines fully on, you're going to have FF down here. If you've just got 1 on, there's just going to be a 1 down here, and obviously here there's nothing's on, and in DB. So when the chip select is on there, look at the data lines. So I purchased this MSO, so as I say, mixed signal oscilloscope. I purchased this lead for the sole purpose of looking at 8 data lines. And what I'm trying to do is actually, now my screen is working, the TFT is working, so you can draw pictures, whatever. I want to capture the data and read the information back from the SSD controller and read it back and store it. I'm having trouble, couldn't establish if the data lines were being shifted, the clock pixel being shifted along, so I bought this £600 piece of kit. So if I show you the leads, in case you're wondering what this is and you haven't seen my other videos, it's Microelectronica's EasyBit Fusion version 7, 32-bit microcontroller running a 5-inch TFT. I've got a 7-inch TFT running a 16-bit, but to make reading this screen easier, I've cut it down to 8 bits. This is the Agilent stroke Keysight Mso Upgrade. So with this bit of wiring and all these fancy clips, see if I can, you've got these leads, plug onto a little pin, and you can press this. Probably can't see it on this camera, but there's a little grabber on the end. So I've set up the 8 leads, put it onto the first 8 channels, and that's what I'm capturing on the scope. So that serial decode you saw isn't anything to do with this MSO upgrade. This MSO kit, so this and the license, I think £495 plus 20% VAT. The serial decode, although I'm running the 30-day trial, the serial decode's about another £377. Farnell are doing a deal, doing a package at the moment. You can upgrade the rest of the software on the scope for a fairly good price at the moment. And it's Christmas coming up, so I'm going to get my partner to buy it. Now that I've established my scope will work and will serial decode data. If you're looking to buy the MSO upgrade for your 2000 series Keysight oscilloscope, you need to be aware of what you're buying, maybe, or maybe you want to be aware, or maybe you want some additional information, so hopefully this video will help. So this is the box for the MSO kit. Someone else wrote on this. You can see I got it from Farnell, and if you look up this part number, I don't know if you can make that out without focusing, 190405, £495 plus the VAT. And that's what you get. Get the leads, get the license. Hopefully you can see the license there inside the box. So you do get the license with the leads, but at a cost of £600. And so what you're getting are 8 additional digital channels. So they're digital, so they're not going to give you any analog readings. So here's the regular analog channel up here, and because there was less captures per second because of the amount of time I was capturing, you can see the waveforms aren't square anymore. But if you look at this digital line, a digital line can't give you a sloping curve. It's either on or off. Can't differentiate between, partly on and partly off. It's either off or on. So where you've got the difference in the middle, where the changeover from off to on, you get this block. So that's where it's turning. It's taking time to turn on. So you just get this block. But on the analog part, you can see and measure how long it's taking to turn on and off. So there's your 8 digital lines, 0 to 7, 8 lines. So that's the MSO kit. So hopefully this video has given you some insight to the MSO upgrade and serial decode upgrade for the 2000 series Keysight oscilloscopes. Thank you very much.